team sponsor challenges, and then we do a break. Okay, and then we do a short break and we meet outside for a group picture on the parking space, and then we start with a second round of pitches, including the gold sponsor challenges, and then we have a round of thank you, and we have some more surprises. All right, let's start with what happened the last few days. All right, we already, well, you know, our photo team has been running around. Who of you have seen their photos on the WhatsApp channel? The links, the Google Drive, hands up. Okay, that's a lot. Nice. So those who didn't check, our photo team did a nice selection of everyday's photos and shared them with all of you in the Google Drive. Feel free to use those photos, share, post, whatever you like. And we have some impressions of the last days here for you, our nice group picture, the first days. So what happened on the first day? The sponsors were here on stage presenting their industry challenges. The teams then decided which challenge to tackle and which team to choose, and they brainstormed and did an idea. And then on Wednesday, everyone decided which challenge am I going to take and which team I'm in. And then we had Thursday and Friday, where all the teams really dug into building a prototype, solving problems, programming, coding in the workshop. So that was 2 days of full working, and today we are at the last day. This morning everyone is still working, and now we are at the end of this Makeathon, where the teams present the results. So here we see some impressions of teams having a good time, working with robots, doing machine vision, doing some soldering. So really nice stuff going on. Every evening we did the evening pitches, so like a short status from the teams, what was going on. And after that we had a nice evening, maybe having a beer together after the event. And yeah, I think we had a really good time. I saw you having fun, but also working hard. So I want to say, first of all of you, give a big applause for yourself for what you did. All right, so let's start with the pitches. You're going to be on stage next. We start with our friends from MVTec, the MVTec Sensation teams. Please come up on stage for your final presentations. Welche Nummer ist das?
Das ist 1 und 2.
Okay, das ist Nummer 1 und das. How many mics? Two?
1 oder 2, ja.
Braucht den Präsenter? Geht ganz in die Mitte.
For the last time, what's up, guys? My name is Anis Ökamam, and I warmly welcome you to the final presentations of Makeathon 2025. And together with MVTec, we are proudly here to present you our challenge, which is the smart automation automated waste detection solution. And first of all, I would really like to give out a big shout out to the whole ITQ team and the whole MVT crew for doing all this for us. And since we are in good hands, thank you very much, guys. Yeah. But what did we do? So our motivation was, since we are in Gran Canaria, we have so many beautiful beaches. But it's not just people who are at the beach, it's also pollution. And to find a solution against pollution, we cooperated together with the MVT crew to design a robot which detects and clears the beach and takes away all the trash. But since our project was a bit bigger, we divided us in 4 subgroups, and therefore I would like to start with the trash takers. So yeah, I'm in the trash taker group, and with our fabulous team, we call ourselves the eyes of the system. What do I mean with that? Like our mission was to detect and locate the trash at the beach, and therefore we used a USB camera which was attached to the vehicle. But what have been our tasks in the last couple of days? We collected and labeled our image data of trash items, like you can see in the pictures, and used it to train a deep learning model for object detection. What I mean with that, I will explain that soon. But we also used the fabulous programs from MVTec. Thank you very much for that. You can get them afterwards at the MVTec Zelt. But we also calibrated a camera to calculate the distance. So what exactly did I mean with object detection? In our case, that object is the trash, which we are trying to identify with a certain training. And for the training, we made a data set of 200 photos for identification, classification, and labelizing of waste. And we also use Python. But what have been the results? Have there been results? Have there been achievements? Of course, we had an accuracy of 98%. That means that in 98% of all cases, the camera detects the waste in the right way. If you are under 2%, I'm really sorry. But instead of just telling you, I would rather like to show it to you guys. Yeah, as you can see, the camera detects the trash and categorize it. As you can see, the different colors which are appearing, and one means for 100%, which we from the MVTec always give. And the biggest achievement for us has been the fun time we had and all the flawless teaming. It was such a great time, and I would like to give to the Sensation team.
Hello everyone, I'm from Team Sensation and we are really excited to share our results with you today. As has been stated previously, we've been working on the MVTec challenge, and the task of my team specifically was to integrate more sensors into the tracked vehicle platform, as you will see. Our goal was to enable reliable velocity control and obstacle detection, for example, if the robot needs to drive up a slope or detect obstacles while backing off behind the robot where the main camera obviously can't reach. This supports precise path following as well as the aforementioned adaptive behavior. We approached this by integrating light barrier fork sensors on the gears which drive the tracks in the back of the robot, as well as a panning servo with an infrared distance sensor at the back of the robot. To illustrate the advantages of velocity measurement, imagine that the robot is meant to drive in a certain direction, but due to deviations such as disturbances such as the slope of the terrain, it may deviate from the path if the velocity isn't precisely controlled and end up somewhere else. Using odometry, however, based on the measured velocities, one can, for one, determine where the robot is going to end up, and one can avoid such deviations in the first place by implementing closed-loop control. One major challenge was to implement some filtering, as you can see here, an unfiltered signal, and after the filtering on the Arduino, which is under the robot, it comes out much more cleanly. We then fed back that measured velocity onto a controller running on the Arduino, and together with the 8-bridge DC motor and velocity sensor, closed the control loop. You can see a demo here without sound, would be better. If someone grips onto the tracks, in the open loop mode, the tracks just stop, whereas with a closed loop control, they resist this disturbance, and in case of slope, for example, the robot would continue to drive upwards that slope. as expected. So we achieved our goals. We communicate the velocity signals to the higher levels of the navigation algorithms, and we implemented closed-loop control, which prevents disturbances or compensates for them in the first place. That's it from us. I'll hand over to the next group. Thank you for your attention.
So that means after the trash trackers, there's gonna be the trash takers. We developed a concept for the home and trash station and did an initial approach of if we want to use a shovel or a gripper arm. In the end, we decided for the shovel because we said it's better to use on sandy surfaces as used in this case and even easier to product. After that, we started calculating about the kinematics before even starting modeling the whole thing in CAD. In this picture, you can see the wooden construction that is used in the end to load the trash there, but I'm going to tell you about the function just a little later.
Here you can see two prototypes we did from the excavator bucket, and we had some problems with the first prototype, so we decided to make another one, and with the second version we had solved all our problems and then gave it to 3D printing. And here you can see the assembled system and also which materials we used. We decided not to print every part and also use wood because it was faster overall. And this was one of the most important moments for us because we only had the CHD model of the parts till earlier today, and when we fitted every part together and realized everything is sticking together and also works as expected, we were really relieved, guys. And this is the final product, which we then mounted to the front of the robot.
And this is how the whole project is going to work. The robot levels up or aligns with the trash, then scoops it up. After scooping it up, we close the lid and go back to the home and trash station. Standing on the platform, putting the shovel to the front, leaving the trash there, and even able to put it into different of these trash bins. But the all-over experience, what did we learn? Some of us learned how to work with the CAD software. We did a lot of progress optimization because we needed to divide ourselves into different sub-teams and needed to report everything about every step. We needed to adapt also to a lot of circumstances like the availability of tools or even knowledge. But most important, we learned a lot about teamwork. We grew together in such a short time and want to thank again for our support and collaboration with our sponsors.
So we are the last team, we are the navigators. Sadly, you don't have a lot of time left, so I will do it really fast because we have videos of our prototype. We were the connection point between all of the subgroups, and we implemented it in our program. So we implemented a search pattern, navigated to detect a trash, and returned to our home base. Here you can see our search pattern, which is right to left while moving forward after each iteration.
Oh, sorry.
Sadly, we have sound, but. Then we have the navigation to the detected trash. We get the position information from the image detection and align the robot to the detected trash. And afterwards, we drive to the trash and collect it, as you can see there. And at the end, we return to our home base. We have two pylons, which can be detected by the robot, and he can align himself and then drive onto the ramp. So, thank you very much. See you later, Navigator. Thank you to everyone, and also the sponsors.
Thank you so much, all of you from the MVTec team. So I think your sponsor wants to say a few words. You can maybe even stay close, no? Yeah, come back here, I'm sorry. Right?
Yeah, okay. No, I just wanted to say we came here and thought about what challenge should we bring, and we were really fearing that nobody wants to do this challenge. So it turned out not at all like that. We had 20 people, and I think everybody learned new stuff, including me. I learned what kinematics is. I learned that the rover can do a Wi-Fi access point on its own, stuff like that. So it was really cool, and thanks for all of you to join the MVTec challenge. And thanks for ITQ for this cool event.
Thank you. All right, up next are our friends from Igus and the industry challenge from Igus.
So können wir das muten?
Ja. Wollt ihr den?
Ja.
So, hello once again. This is honestly taking stage fright to a whole new level. First of all, I want to give a massive thank you to all the event organizers, all the crew members, the sponsors, ITQ, Igus, for providing us with all the equipment that we need, and our team. And yeah, let's get started. So, we at Team Grow SmartBot have this concept of a smart greenhouse where the different modules, there are different procedures that all in all combine into a robot that is going to harvest all the plants, fruits, vegetables, and put them into another station so it can be organized, sorted, and hopefully give out products. And we want to make it so that it would be affordable for everyone to be able to implement this solution by themselves. No need for any high-end expensive equipment. And yeah. So first we have the setup of the robot, which Simon will explain.
Yes, so we use the Rebel from Igus as our main robot, and we combine it with the linear axis, and we use the Igus robot control software to program it, and the linear axis, for that we use the D1 drive system. And now on the next slide I have a short video which is this is our basic concept. So we use cardboard boxes instead of actual plastic trays just to demonstrate the case, and we're going from the bottom in and just tilting the end effector up to let the box slide onto the robot. The next step, we're going to move the linear axis to a second position where we have a second, where we place it down so it can slide down the ramp for the next station, where we have the possibility to implement a vision system and sort different objects.
Yeah, so afterwards, this station, there's a camera implemented at the top in a sort of bird's eye view mode, which will classify the different fruits or vegetables based on the stage, the ripeness stage that they find themselves in. The model that we trained has been looking pretty good, and it can also discern in what stage the fruits are in. And the database that we used is from RoboFlow. It's linked down below. And we used a YOLO version 8 model to train this. Yeah, and what's next? So we can further expand this project into including all the other modules that will come together to form this smart greenhouse. This was only a really small part of it, which we tried to achieve in a few days, and hopefully it worked. So yeah, low-cost automation is our goal here, and it will be possible with the equipment that Igus has provided us. And yeah, we can hopefully make a smart greenhouse one day in the future where everyone can be able to farm and harvest their own plants by themselves in their house in as little space as possible. And here's also a 3D model of the whole assembly. You can also scan the QR code there to have it on your phone. Check it out for yourself. As you can see, the stations are there, and there's also the camera, and there will be also another robot which would sort the whole fruits and take them to another station for further processing.
So if you scan the QR code, you also have the possibility to to use it as an AR model, so you can just put it in the room and see for yourself.
Thank you very much.
Thank you.
Thank you very much. Checken wir da den QR-Code?
Oh, sorry.
Ja, genau.
Sorry.
So take the chance to scan that QR code if you want. That's some really cool view of that Igus demonstrator. Thank you very much. Good job, guys. All right, up next on stage we have our, well, you all know them because they have quite a big prototype, our friends from Moore Electronic. Okay, we have even some live demo coming up. We're going for the risky one. Presenter.
All right. Hello, everybody. I hope you had just as good as days as I had the last few days here with the Carnival and everything. Actually, I had just been done with Carnival back in Cologne, but, well, here we are. All right, let's start with the project. I hope you still remember the green box that Patrick, our mentor from Moore Electronic, talked about, because today we brought you this very green box. All right. Okay, so of course this is not our prototype. I'm pretty sure you have seen our prototype, because how could you not? But this little green box will help us today to show you what we can do with our prototype, and of course later today you can see the proper prototype in work. All right, let's start with a short recap. The challenge that we were facing is the waste of plastic. Every year, 500 billion plastic PET bottles are getting produced, and so are 500 billion bottle caps and much more plastic in general. And 30% of this is getting recycled, so it's not much. And the rest of it will go to waste in the ocean, get burned or whatever. So what can we do with it? We can, for example, shred the caps, shred the plastic, whatever, and use it to seal electronic parts, and use it for a good reason, because one man's trash is another man's treasure. And let's see how we do this. Enjoy.
It's okay. Okay. Hi, I'm Mirko from the team Automation. Our task was to merge all the sub-process to one fully automated process. For this we used the For this we used the PLC from Moore. But long story short, sorry. We merged the different sub-process to one fully automated process. But long story short, I think the best way to explain our process is to show it to you. So if you want that I start the process, make some noise for Team Moore, for the ITQ and the Makeathon, and I will start the process. Oh. You have to listen.
Thank you. Hello everyone, I'm Tim from the Plastic Procession and Shreddering team. It's a really complicated name, but yeah, our job. Oh, I need a pointer. So, you see a plastic fork. Our job is it to process, like the name says, the plastic parts. So we use for this a shredder, because this fork is way too big and it doesn't fit into the molder. That's why we use a shredder. And the shredded parts go through a hose that is vibrating by electromotors because of to prevent electric friction. And yeah, then it gets into the molder where it gets heated up to 240 degrees for 30 seconds, and then it gets pressed into a form so we get our product. That's the shredder. Yeah, sorry. Pardon. Ah, sorry, yeah. So, we start the process.
Okay, let's talk about how all of this works. I'm Ines from Team Robotics, and I'll be telling you what we did. So first, from our little green box, we find this little mold. Inside of this mold, we put this PCB. We want to place this inside of here, and then we have a topper of this one to close our mold. And then we want to fill all of this with plastic, so the PCB is sealed and protected. Now, how do we move it to the molding station? First, we use a Delta robot to place the PCB on the mold. Then we use the Igus cobot, thank you to Igus at this point, to move it back to the molding place. And then we place it in here, and we start the molding. But of course, all of this is automated. Let's have a look what all of this looks like. Okay, now that our mold is in a molding station, how do we keep going now? We got from Team Plastic these little pieces of shredded plastic. Now we want to liquefy these and put them into the mold. For this, we first have the molding station. And we built this very big construction, which all of you have probably seen. I'm very much assuming. So first we have this little lever that we put around so we can place the little pieces of plastic into the molding station. And then we pull the lever down so it'll press hard down on it and we create the mold. Of course, it's automated. Let's have a look. Here you can see the robot which is pulling the lever so we can fill the molding station. And now we want to pull the whole lever down so the molding will be set in place. Here you can see it's going back up, but first it will go back down. So at this point, we get our mold filled with the plastic and we take it out. Now we want to put it back to the starting place where we can untop it. So first we go back in with the Igus cobot, and then we use our Delta robot again to get the final piece of plastic out of there. Of course, once again, let's have a look. And there it is, our beautiful finished product. So now we have this nice green product here. But now I'm wondering, how do we get it smart?
Thank you, Ines. So yeah, this product is already pretty green, but we want to identify how to make it even greener, and one way is with electricity. So we started with Shelly plugs to measure the electricity of the whole process. After that, we had to engineer an interface to save the data of the Shelly plug into a cloud where the raw data is stored. And afterwards, we also had to program a interface to then further use these data into an AAS, an assessment center. Yes, sorry. Because what we are interested in is the CO2 footprint. So the CO2 footprint is then stored into the product, the digital product passport. Sorry for that. Where you can see the interface on the next slide. So this is the passport. It's like a data sheet but digital, and you can store a lot of data in there. And on the downside here you can see that with the energy mix of Gran Canaria it's 47 gram for this product, which is pretty high, but will decrease when the energy mix of Gran Canaria turns green with the use of more solar and also windmills.
Yeah, first we want to thank our sponsor, Moore Electronic, for giving us this great challenge. Next, we want to thank ITQ for organizing this event, and Igus robots for preparing the robot that we used in our challenge. Furthermore, we want to thank the members of the universities from Bremerhaven and Kempten, and the partners of H2BX for their help and support in our teams and challenge. Please come to our booth at table 17 and see our prototype in full motion. Thank you for your attention.
Thank you so much. Kannst du mir das Mikro geben?
Hey, guys, just wait a second. Hey, I'm so proud of you, to be honest. That's need to be said. Hey, sitting down there watching this really amazing presentation, I could not believe that you did all this within these 3 days. Really amazing. A really big applause from us, from Moore, for you. Thank you so much.
Great. So, up next on stage we have group number 20, our friends from Wishai, the Waste Hunters. Let's give them a hand. Just in the meantime, if you check on the announcements channel on WhatsApp, we have the full setup for you there, so the next team can already prepare so that you're ready. Ja. Ihr könnt ruhig ein bisschen move to the front a bit.
Hi, as you probably already know, we are the Waste Hunters, and our vision is to make the world a better place, or to be more precisely, to save our beautiful beaches from problems that affect nearly all of them, because 10 million tons of plastic waste end up in the ocean every year. That's like 2 truckloads of plastic ending up there every minute. And the plastic, it doesn't simply disappear after some time, so even the grandchildren of your grandchildren, when they visit the beach, there probably will still be the plastic that we are using today. And yeah, 60 to 95% of the waste consists of single-use plastic. But when we learned about 40% of our plastic gets into the ocean via the coast, we created an idea, and yeah, this is our idea. We created 2 prototypes, one that can collect waste automatically and the other one that is very easily to control from all over the world. And yeah, this was our idea, and we'll present it to you now.
So first of all, we want to present you Limp E. His feature is to clean the beaches with its built-in transportation system and his robot arm. And by reducing the beach pollution and creating cleaner oceans, LIMP-E is contributing to a better planet. And this is our future of waste collecting, where we don't have to rely on people who don't care about our environment.
Okay, so for the creation of our prototype, we split the team in 3 groups. The programmers developed the code for the navigation and the pickup function. Meanwhile, the electricians implemented the waste detection by camera. And the mechanicians created and built a gripper to pick up the trash.
So now we want to demonstrate how LIMP-E will pick up the trash. Yes. But as you can see in our real-life demonstration, he's detecting So first of all, he's detecting through the camera the waste, and after he sees the waste, he will stop so he can navigate slowly right in front of the object. After that, he will set the gripper into the right position and then bring the object in the back on the tray so he can go to the next one. Like you can see it in a minute again.
So normally you would have seen a video from our first gripping tests, but sorry, this doesn't work. So our gripper was possible to grip a variety of different items like 3D printed material, empty chips bags, a can, even a diffused can, and a cigarette box. But we can't show you now, but you can look at it later on our table.
Hello, everyone. Perfect time. Hi, everyone. I'd like to introduce Grasp, our second robot, as part of our challenge. So the project actually began when I arrived a little late to the Makeathon, and Vishay was the only actual team left that had no members. So I asked them, okay, what are you guys working on? They said, hey, listen, we want to use AI to pick up trash on the beaches or on the streets. And I said, listen, I do robotics and AI. That's not going to work. What is another solution that could work, given today's climate of AI? Trash is everywhere, needs to be cleaned. We can keep on spending money researching in AI, but what are existing means and technologies that allow us to actually pick up trash? We thought of, okay, what if we do low latency teleoperation with WebRTC? So the idea was pretty simple. Could you create a program that allows anyone from any part of the world to control your robot and pick up trash on your behalf? So what we did is we created our custom robot called Grasp, and what this does is it uses your hands and a laptop's webcam to actually control the robot's arm, and we can use the keyboard to drive it around, and it works from any part of the world. So we'd like to do a quick live demo for you. So one thing is that the robots, we can drive it around. This is very basic. RC cars do this. But what makes this different is that we create our own robot arm. And this robot's arm uses any laptop webcam, no specialized hardware required. So current means of teleoperation actually require so current means of teleoperation are very expensive. Use virtual reality, augmented reality, and these things are add to the cost of actually implementing this kind of software in real life, day-to-day life. So what I have right now, if you see my hand, is I'm just pinching, and I can open and close the gripper just by pinching my hand. As I move my hand left and right, the robot follows me. So you can imagine in an ideal circumstance where this robot is out in public, someone from another part of the world could be teleoperating this robot remotely. No advanced artificial reinforcement learning required, and yet the robot can pick up trash effectively and clean the streets right now. Yes, do we need trash? Good question. Guys, blame the trash, not the robot.
So we were a young, dynamic and international team with a large knowledge range out of many different areas of study. We would now like to give you a closer look where we all came from. So we had guys from Cuba, Brazil, Morocco and from Malaysia, and also a large group of people from Europe. So we even had someone from the Great British Kingdom, a lot of people from Austria, and also a couple of Germans.
And last but not least, a big shout out to Vishay for providing all the materials that made this solution possible. And thank you for helping us creating a cleaner, healthier planet for our future generations.
Thank you so much, guys. Great job. Awesome. All right, up next on stage, Papas Arrogadas in Mochopicon. Go. Unit 2 and the presenter. They should play themselves or we start them.
Hi, we're two teams. We're Team 3, Papa Harroga, and we're Team 31, Mojo Bigong, which is a very famous Canadian dish. This is our team. It's very Canadian too. We have a bit of a mixture here, but all Spanish. And this is our objective. We are partnering up with EduDemos to make some sustainable demonstrators, and the point is to create some interactive and easy to assemble demonstrators so that kids and teens can build them in workshops and actually understand how renewable energies work, to see them working in real life and to actually get how they perform. We basically started with some sketches, we did some 3D modeling and printing, and then the assembly and testing. And I'm gonna let my partner talk about one of the two demonstrators that we did.
Okay, so the first demonstrator was a water prototype. This one will work with it's like a dew collector. This one will catch the water of the humidity that we have in the air, and through the net, the water drops will fall, and in the store, in the little thing that we have in the bottom, we can collect all the water. The main point is the net that we have there. It has to be a really special net, because if not, it will not actually work pretty well. But this one is working very well. And we have also a lot of electronic components. These one are a water level sensor and a humidity and temperature sensors. I don't know if you can tap it. So in this one, we can see how by, like with the fog, we say, like we are simulating the fog, you can see the little drops of the water falling, and it will go there. And with the other one that we have there, you can see how, like if we have a red LED, it means that it's empty. If we have a yellow one that will change now, it means like it's a medium, more or less. And when the green LED will light, it means that the tank is completely full and you have to empty it. And then in the little display, you can see like the humidity of the air, the temperature, and also it says like the status, like it is low, medium, or high.
So the next one is the solar prototype. Basically what we wanted to do is that we made kind of like a two-in-one demonstrator. So we had the water top prototype, and changing just a few models, we have the solar prototype. So basically how it works is that we have the solar panel in the top that collects the energy and also detects when there is light. And we have a rotating axis and the magnetic leaves that open and close. You can see all of the electronic parts there, and the axis that goes in the interior, that's there with a lot of magnets. Okay, so the point is that when the solar panel detects that there is light, the leaves open. And when it detects that there is no light, the leaves closes. Kind of representing how it's collecting energy and when it's not collecting energy. This is based of an endemic plant from the Canarian Islands, which is heavily endangered, which is the Cresta de Gallo de Moya, which is almost gone extinct. And the previous water prototype is based off the Tajinaste, which is also an endemic plant, but is located near Teide in Tenerife. And well, this is what we achieved. We're hoping in the future that we could add a wind turbine, a wind demonstrator, which is not impossible to do. We already have the axis, and we planned everything so we could be modular, easy for assembly, and interactive for kids. We are very thankful for this event. We had a great time. We had a bit of ups and downs, but finally we managed to actually make functional demonstrators. We don't have them here, but you can come to our booth. We will be really happy to show them to you. You can ask about it. We can like assemble them on and off so you can see both parts. And actually the solar one works because we've been powering it up the entire day under the sun. We have two of our guys the entire day out there getting hot. But yeah, if you want to know anything, ask us anything. Thank you very much.
Thank you very much. All right, up next on stage, we have the 3IQ team. Let's give them an applause. So just make sure you can check the order of your teams in the WhatsApp group, so you can already be prepared, either on here or on this side. All right, 3IQ. Let's get John.
Hello. Hey, wanna have some?
Oh man, oh man, oh man. Look at this young fella here. You want some of that good stuff? I got some renewable energy for you. That shit ain't good. Well, you know what is good? It's our project. We worked on the solar thermal demonstrator. making nice plans, 3D printable for EduDemos. So it's like a kit you can print for your kids or your school members, and you can build it together. In this instance, it is just like mirrors that are reflecting light onto a surface on the top that conducts heat and measures it. It has like really nice details. You see those? It's really amazing. It's like foldable and really aesthetically pleasing. Yeah, next slide. And this amazing wave power plane demonstrator, it's like a duck, but like threads in water. And does this little walkie walk like this. Yeah, it's amazing. So it generates energy from its feet and like uses it to like into his little eyes, and yeah, it's a jolly little follow. All right, so now for the final act, let's summon EduDemos. Bring up us. Teach us your ways.
Have no fear, my child. Have no fear, my child, for I will give thee salvation. The mirrors concentrate the solar energy upon the heat converter in the sphere up there. Thus, it appears, the temperature, thus I grin. I also bestow on thee a duck. It converts the power of waves into movement and sound. Come on, EduDope. Join me. Join us on our crusade for renewable energy.
All right, thank you, everyone.
Thank you very much, guys. All right. We have up next the team Siftel. Well, let's see what they got for us.
Well, this was really great, our Rosenheim friends. Yeah? This was really great. Yeah? It's always a pleasure with us. Yeah? You're not easy, but very good. Where is Tobias? Come on stage. Well, last time you had Hug Me. Well, he's a great guy, and he has always some funny guys and girls with him. And, well, I really want to thank you. It's always a pleasure to have you here.
Yeah, thank you for the event and inviting us every time again after our crazy shows. I hope you enjoyed it, and thank you very much for this event and that you invite us every time again.
Yes. Sometimes I hate you, but... But at the end, I love them. Okay.
All right. Up next on stage, the guys from Siftel. Let's give them a hand. You need the presenter?
So, hola, hello, good evening, everyone. We are Siftel, and yeah, this is us. We are the powerful combination of civil engineers and telecommunication engineers from the University of Alcalá in Madrid and the University of La Laguna in Tenerife. We try to bring here our unique skills and combine them in this big event, and yeah, try to make the best of it. So this is the main idea we had for our project. We have chosen Lawrence as sponsor, which they work on modular and scalable water flow measurement, and yeah, it aligned perfectly with the things we wanted to work on here. Our main goal was to develop an intelligent network that enables scalable and efficient data analysis. So these are some of the challenges we approached first starting on this project, improving water resource management to protect the planet, raising awareness of our environmental impact, and some of the solutions like engaging households in a quick, convenient and effective way. Basically all this thing you can see up there. In short, I'm a civil engineer. Mostly my work and study is related to hydraulic and water flow, and I've learned a lot that it's very important and we need to keep coming up with these effective solutions. And these guys I met here, they are incredible. They knew all about the telecommunications, so we created something together. So yeah. Here you can see a bird's eye view of a house. And this is what we've been working on. We have a thermostat which has a humidity sensor and a temperature sensor, as well as the Lorentz water flow sensor. So this will be the device we worked on and will be implied in all of the household. So this is a beautiful bird's eye view and front view of a building. From a single home to an entire community. So basically this device will be in any room of the house. We plan it there, and yeah, it can be, actually I'll show you the next one better, the next one, yeah. Because there we have how this system works, the MQTT network. So first of all, we have the Raspberry main part that tries to take the information from the sensors. And we have three sensors: the temperature, humidity, and the water flow. And these sensors capture the data, and then they publish it online so we can consult it in a monitor. So you can see now the next one. Yeah, we have there a displayed sensor in real time where we can access to this data. So basically this device is connected to wirelessly to a Wi-Fi, and it can be accessible through our smartphone devices. And yeah, we can get access to this data and try to save up, and that's the way we came up with a sustainable project here at Makeathon. So yeah, I think that's the presentation, and here we have a short video of the prototype. So yeah, that's the main part, the Raspberry, connected with the temperature sensor there, and there we have the water flow from Lawrence, which is basically circulating water, and there we have the monitor, which we can consult and analyze the data in real time. Thank you for your attention. Thank you very much.
Thank you very much. Thank you, Team Siftel. Up next on stage, you might have seen them flying around today, the H2 heroes. Go, go, go. You're missing someone?
No.
Okay.
Hi guys, my name is Luis. We are from I'm from the H2 Heroes. We are a very small team, and we had a few challenges, like we built a hydrogen shark at the very last moment, a little boat powered by hydrogen, and our main project, the Zeppelin or airship. So this is our airship. I think you saw it today, and that is coming. We've done a lot of soldering work there, and hopefully it doesn't explode. Just kidding. We had a few test flights, and the program is working on ESP32 motors, and this should be a video of the Zeppelin flying, but okay. I think that one is much more interesting than the video. This is our little hydrogen boat, powered by a fuel cell, and we try to build another version of it with much more engine power. And thank you for your attention.
Thank you so much. Thank you so much. Okay, let's enjoy the landing together. Maybe we can all while we're watching, you can already come on stage. Team 14.
So, hello, hi, guten Tag, buenas tardes. We are a team, let me say it, SRAADRGC, an easy name. So, autonomous differential robot with garbage collection. So, in the island, there's a big problem. There's a lot of garbage in public spots. So, for that, we have this solution. I'm not going to say it again. Can you go to the next slide? So, we are a team of 5 members. We started from completely scratch with that paper. Then we made some improvements. Next slides, please. We have integrated a computer vision program detecting just the color blue, as this is a prototype. Also getting the coordinates of the centroid of the figure. Next slide. And then we divided can you put the video? We divided the team, and the other team worked with collision avoidance. You can see it in the video. It's pretty neat, I gotta say. Next slide. Please, thank you. This is the final product. I know it. It's beautiful. And in the next slide, we have a video of it working. So as you can see, it can detect the trash, it does micro adjustments to get to it. It can be improved with a wider angle cam, and it can do also obstacle avoidance with the sensors. So after that, in the next slide, you can see it. There, in the last video, it didn't have yet the collision avoidance. And for that part, for this part, the guy that is gonna talk is Nick, our youngest member, just 18 years old. And let's go.
Yeah, hi, I'm Nick. I'm from Germany, like most of the people here. And I'm going to tell you something about our experience, or more specifically my experience in this team, being the only one that's German in this team, because all of my teammates are Gran Canarian. And I had a great time with my team. I was brought in immediately, I helped a lot, and those and those guys showed me, well, not just stuff for the project, but also stuff we can see on Gran Canaria, like for example, those chocolate bars we had on the event that they're produced here in the island. But I also learned a bunch of stuff, especially for the project, like for example computer vision or getting to know hardware interfacing a little bit more. But yeah, I had a great time in the team, and it was fun working with everybody on this project.
So, talking a little bit about our members, fastly. Nick Foster worked on the robotics, structure, and obstacle avoidance. Juan Pereiro over there worked in computer vision and garbage collection. Adonai Hernandez Bolaño worked in robotics and the garbage collection. Jeremiah Garcia worked in robotics, and me, Oscar Muñoz Hidalgo, over here, worked in team leadership, computer vision, and garbage detection. Last slide. So we're going to give the thanks to every one of you. The Escuela of Ingeniería Informática de la ULPGC, with our teacher, José Daniel Hernández Sosa.
Yeah, and I also want to give thanks to the BBS IFA, which is my school. And yeah, I hope you enjoyed it.
Thank you so much, guys. All right. Thank you so much. Up next on stage, we got the team FarmBot. Let's give them an applause. Okay, for the next teams, if you are not prepared yet, when I announce you, you have to run, okay?
Thank you.
Thank you.
So, hello everybody. I'm Rodrigo from the Agrosos project of the FarmBot, and first of all I want to excuse ourselves because this presentation was supposed to be together with the Team 40 of the tractor, of the solar tractor, but some things went wrong with their project and they can't be here because their project failed from the beginning, so we only can do the FarmBot part. Please. Hold this. So, in these projects, we have worked 3 different institutions. The ES Luis Vives from Madrid, where I come from. The ES El Rincón, from here from Gran Canaria, which were the tractor guys. And the fellow Monzon, which work with us in the FarmBot for all the plant stuff, because they are the farmers in the project. So, I'm sorry guys, I'm really sorry for them. Coming back to the FarmBot is basically an automated farm which can irrigate, plant some crops, and control the plagues by itself. I'm going to divide this in these 4 stages of the project: the material gathering, planification, assembly, software, and the final test. So for the materials, apart of the robot parts, we needed somewhere to put all to assemble everything. So we made kind of a wooden surface with pallets for being able to construct that. This is our team working. This is how the machine came. Already was almost most of the wiring and that stuff was already assembled, but we have to put it all working. For the assembly, it ran on tracks. It ran with 2 different tracks by the sides, as you can see in the video, and a vertical arm, which is the one which makes the most of the job. This is all the steps we took for the assembly. Our team building the main structure. Thank you, Jose, who isn't here, which was like the leader in all this. Then we went to the wiring and all the software, while our companions were planting already the crops. I'm sorry, it's a lot to take. Okay. And finally, we have the testing. I don't know why are the videos not playing.
Let's play them.
It's basically the machine irrigating all the crops and cutting some of the plants we put. So thank you very much for listening to me, and thank you to ITQ for helping us in everything you could.
Thank you. Is the farm bread, can it still be seen downstairs? So if you go over the bridge and look down, there's the farm bread standing. All right, up next is Team Birdbrain.
Hello everybody. Our goal was to expand our knowledge in research data management in large facilities. And it's not easy for researchers to work with data fair. That means the data is findable, accessible, interoperable, and reusable. And for that, they need an ELN, an electronic laboratory notebook. And that was our main focus in this challenge. We used the eLab FTW, and Elena will now talk a little bit about our concept.
So, first of all, our concept was to create an easy deployable system that includes speech recognition, which connects then to a database to enhance all the data analytics used in laboratories. So now, how does it exactly work? For basic communication, we needed a connection between the development environment and the database, which will save the information. And then there's also the audio hardware, which will include the speech recognition and an AI used to detect all the words said, which will then work closely together to have the laboratory notebook for all the for all the researchers.
Now I'd like to talk about our team. We are only 4 people, which is really small, and we all have really different background. Also, we are from 3 different universities. And also we have 2 Apple MacBook and then 2 Windows, which makes really difficult for us to develop something together. But we shared thought and knowledge. We have different knowledge, so we shared and worked together and made it through.
Lastly, I want to talk about the lessons learned. Of course, the deployment or the preparation for the deployment is incredibly hard. No one told me that before. And we learned that the visualization is the key. Like you could see on the last slide, we had to make up our plan for the whole project before we could start to get ahead. And the last thing is that the teamwork really mattered. We really come from different universities, have a different background, and all of this, what we reached today or in the last few days, was put together by us as a team. At last, I want to give a shout out to all the people and to all the institutions which brought us here together and which enabled us to work on this project. Especially to Vitali, our patient guy. Yeah. Thank you. And of course, you can see our demonstrator at our table back at the pavilion.
Thank you so much. Up next on stage, the green bin. Go, go, go. Okay, guys, run, 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 run. Wie viele Mikros braucht ihr? 2?
Okay, we are the green bins. Okay. Waste collection today is highly inefficient, leading to several issues that both impact the environment and workforce responsible for managing it. Overflowing bins, improperly sorted waste, and the need for sanitation workers to manually check and empty bins contribute to wasted time, increased operation costs, and environmental harm. Many cities struggle with ineffective waste management systems, causing recyclable materials to be mixed with general waste, reducing their potential use for reuse. Okay. The solution to these, we address these issues. We developed a smart rubbish bin that improves waste management through automation and advanced technology. Our bin utilizes machine learning to automatically detect, identify, and sort waste into designated categories such as paper, plastic, and organic materials, instead of relying on individuals to sort their waste correctly. Green bin takes on tests with high accuracy, reducing human error and improving recycling efficiency. In addition, our system includes sonar sensors that can continuously monitor the fill level of the bin. When the bin is full or required maintenance, it sends a real-time alert to workers via a centralized SQL database. This ensures the waste is collected only when necessary, reducing unnecessary trips and optimizing collection routes. All right. The prototype, we developed a functional prototype using the MVTec vision sensor and machine learning, thanks to them. Once the system attends to the type of waste, the bin automatically rotates to deposit the waste. There we go. All right. It rotates. Currently, we're only able to sort between a bottle and a bottle cap, and that can only support bottle caps. Yeah. This is our team. We got the carpenter, Arnar, Sindri, me, the data guy, Thorbergur, sensor guy, Kristin, the machine learning guy, and Matthias, the web and graphics guy. I want to thank all the sponsors and ITQ people here, but I want to specifically thank the MVTec for actually lending their vision sensors and the software. And that's it. Thank you.
Thank you very much. All right, up next on stage we have the green engineers.
I'll just start now. Hola, welcome and servus. I'm Marcus from the Green Engineers, and we heard earlier from the Mer guys, for example, that Gran Canaria needs to be more renewable. And that's what we are here for. It is our mission to build a building kit for islands, for any island, any nation in the whole world, to get renewable. So we are working with the example of Curacao, that's an island in the middle of the Caribbean, and so Latin America, and also the Canary Islands like Gran Canaria. Maybe the next slide, if possible. Perfect. The top picture shows the current oil refinery that is not working anymore in Curacao. And our approach would be to to make it a social community hub, and also to put photovoltaic panels on there to produce energy in the middle of their city. For Gran Canaria, there's currently a fossil fuel plant that, for our vision, would need to transform the island would be to place renewable energy on the island so the fossil fuel fades out. And so our approach, islands don't have a lot of plots, a lot of land, a lot of area. Our approach would be the double usage of the available plots. So we combine wind energy, solar energy, and energy from waves. So we can place this double on the land. For example, on the dam, on the water reservoir that is currently planned in Gran Canaria with 3.5 gigawatt hours, we could implement floating PVs on top of this. This brings a lot of positives. For example, the water doesn't evaporate as much, and also the power is directly at the pumps. So we have this cool island from Curacao, and a question is 100% renewable energy feasible? No, it's currently not feasible, because the energy capacity storage to bridge the gap between the days that have no power production is too large if you have 100% renewable. So let's say, for theoretic sake, it's only 99% renewable. Then you would need to have some of these other goals for 99% renewable, which is a lot more cost reduction for these goals. On the next slide, there is a QR code I would like to scan. I would like you to scan it. There are all the information we gathered these past few days. So maybe you can do something also to make these islands more renewable. My appeal is to I think I heard that there are some politicians maybe watching, maybe they are here. One of the current problems is, if you have the ability, if you have the power, the licensing for these power plants, for these renewable power plants, is long time. If you have the power to push forward these projects, it would help a lot. And we as tourists, we as young people, also from the islands we have here, we would love to see, or we would love to travel to these islands if they are advanced. We don't think of renewable energy as cheap, as old. We think of it as advanced, as sustainable for the future for us young people. So a big shout out to my team. We have 3 lovely girls from the Canary Islands that helped a lot with their expertise, and also a lot of people from Germany with their knowledge. A big thanks to Javier Morales. He's an energy expert in the Canarian Islands, so a big shout out to him. And also Dr. Holger Hesse for answering all our questions. Also, thanks to Professor Danzer from the UAS of Augsburg, and please give my team a big applause. Thank you.
Thank you so much. So we have one team that's also.
We're the group from.
That is not quite the Caribbean, but still over the ocean. We have one team from Bogota, who've been working the last days as well. They couldn't make it to show up on stage on time, so they sent us a video, and let's have a look.
Universidad de los Andes in Bogota, Colombia, and today we're presenting to you our Aquaponics STEM kit. First of all, our group is conformed by 9 participants, in which 7 are students and the other 2 are teachers. For our kit, we made up the 2 ideas you are seeing on the screen, which we combine to get the render that's being showed. This render involves a modular design that allows us to have a portable and easy access kit. This design could be divided into 3 larger pieces. Each one of them serves a different purpose in our kit. First, we can see the down chamber, which allows us to store our water filters, our water pump, and also a sensor that helps us to measure the water quality and conductivity. In the second chamber, we can see the aquarium, which is responsible for storing the fishes that we need for the growth of the plant. I can assure you we have them there, but for a regulation of our university, we can't show them. In this aquarium, we measure and control the water temperature and water pH in order to sustain and guarantee a healthy lifestyle and a healthy environment for the fishes. We keep control of these parameters using Arduino Cloud, which helps us to remotely see what's happening in our aquarium. Lastly but not least, we can see our third and top chamber, which we use to allocate the lettuce that's being planted. We created some specific channels using our 3D printers that helps us to control and maintain the water levels around each one of the lettuce roots. This helps us to reassure and be confident that each lettuce is receiving the nutrients necessary for their optimal growth. Even though each one of these chambers has different purposes in their use, we have them all the 3 connected using different holes in order to maintain the water level not only in each chamber but also in all our kit in order to not have the necessity or the needs to add additional water to the system. Finally, we want to thank the opportunity of being able to participate in such a big challenge as the Makeathon, in which we had a very grateful time, even though we didn't have the chance to be there with you. In our facilities, we were able to accomplish the majority of our achievements, and we reassure you that we will continue working on this kit in order to provide the girls between the age of 12 and 15 years a STEM kit that motivates them to study one of these careers. We hope you liked and enjoyed our presentation. Thank you very much.
So, our friends from Bogota are currently live. They can see you here. So if you want to wave at that camera here. And we have parts of the team being live here. I don't know if they know that they're on the big screen now, but maybe we can just wave again and yeah, and then we can.
Okay.
Well, yeah. Wir machen sie mal an. Okay, I will turn this one around so they also understand what's going on. Okay, let's wave once more. Okay, one last time. All right, yeah, I'm really... Was los? I'm really glad they're joining. I had the chance to visit them at the university back in 2018, and I'm really glad that they have motivated people who say every year we want to be part of the Makeathon and give us a challenge. And also this time doing the whole education idea further, developing kits for STEM for younger people. So I really appreciate you joining us every year. And yeah, saludos a Colombia. All right. So up next, we have the group photo coming up. For this, we will meet at the parking space. And line up there. There will be Fidel. Fidel, wave your hand. You remember Fidel? Let's see if you still have some voice after the first photo. Please stay seated for a second. After the photo, please everyone come back here for the second batch of the final presentations. Still looking forward to the gold sponsors. So, see you at the parking lot.
also wir sind jetzt 10 Minuten oder so. So steht da jetzt. Also hier ist die aktuelle Zeit. Also wir sollten eigentlich jetzt in einer halben Stunde. Dauert jetzt eine halbe Stunde. Und danach kommt der Thank You Time. So um 5. Ja, ich denke, genau, also für 5 Uhr denke ich, können wir das machen. Also nicht vorher. Genau, wenn die 15 Uhr sind.
Your seats so we can continue with the second group or the second half of our presentations. We got a few more groups coming up. I'm looking forward to all the gold sponsors presentations, and we start with Livos technicians. Yeah, sure.
Hello everybody, we're Livo technicians, and today we have Nico
and Lucy,
and we're going to tell you about our project, which is the intelligent buffet system. So the problem we were trying to solve was the food waste and poor kitchen management. The chain of the hotels, Livo, from here, asked us to help with this problem because they have unhappy clients with empty stomachs, which is not very good. For example, kitchen doesn't really see what's happening in the buffet, so they overproduce soup, and we have a lot of soup that nobody's eating, or we don't have, for example, French fries, and clients are unhappy with that.
Exactly. We from Livos Technicians have a solution to all of these problems mentioned before. We call it the Integrated Buffet Management System, or Buffet Busters. We have, our system includes both the hardware here and the software for you to have a pleasant buffet, which means a pleasant buffet for you and your employees, and of course for your guests. On the next slide, you see our prototype. It's a case which can, it's a case which can contain 2 trays, one big and one small one. And on top of it, we have a camera with a Raspberry Pi, which uses OpenCV in order to detect how much food is left in the tray. And the real magic happens in the software. So here you can see the, you could say, POV of the cook or of the kitchen staff. You have a nice overview and a neat UI over all your dishes. And you can see here, for example, you have the overview over how much food is left. So that's the first big advantage. You don't have to go out in order to look. You can have all the overview in the kitchen. And we are using a recurrent neural network in order to predict when the food will be empty and when and if it has to be replaced. It is not only intelligent, but it can also learn from your specific needs. So if you have our system in production for 1 or maybe 2 weeks, our neural network will get better and will adapt, make better predictions. And last but not least, we have a waste management tool, which means if you remove the tray from the case, the system will detect that and will automatically protocol how much food you wasted in order for you to do deep analysis on how to minimize food waste.
Now we're going to tell you a bit about our team. We divided into groups such as hardware, software, creative division, and special agents, so the guys that can do basically anything. And we learned a lot during the project. We learned, firstly, not to trust too much the Chinese-produced devices. We learned that we want to be creative. If the plan A is not working, the plan B is not really working too, and the plan C is not working as it was supposed to be, you have to look for many diverse solutions. And also, we learned that the communication is very important and the teamwork is what matters. And we would also like to thank the sponsors, of course, ITQ, also Innovation Canarias, and Fundación Sergio Alonso. And last but not least, we would like to thank you, the other guy, which is unfortunately not with us anymore. Don't worry, he's not dead, he just went back to Fuerteventura, but the project wouldn't be possible without his help. Thank you.
Thank you very much.
Thank you so much. Great job. Up next on stage, we have the Smart Buildings team. So they prepared really well, but they didn't show up. Okay, I will find them. They are there. Oh, okay. Let's give them another hand.
Sorry for that.
That's okay.
So, good afternoon, everyone. I'm very glad to be here representing the team of Smart Buildings made by the EIS Rincon. So, to introduce our project, we need to know the problem that we are gonna make in front of it. And to start, we need to know that Gran Canaria is an island that consumes more than the normal electricity of the average European city. So with 8.8 megawatts per habitant, this energy is coming from the buildings like 16%. And with this project, we have the opportunity to save up to 25% in our electricity bills. With this smart project, we are turns every watt into an opportunity to our planet. And we need to tell everyone's the part of this project. So we brings you a website that provides not only measures of temperature, room, humidity. We can also optimize it and see what we are doing in our homes. So we have our smart sensor network with some smart sensors that send information to our MQTT servers that process that info and show us into our web server that brings us some information of temperature, humidity, light levels, and etc. So now I will leave you with my teammates, Thiago.
Okay, so hi everyone, my name is Thiago, and I hope that you are enjoying this moment, so do I. So actually, when I was thinking about this project, I was like, how is it possible to analyze data, energy, and more cool, more interesting? It's not like the simple monitor that we used to. No, we've created a fitness track, but for buildings energy. Actually, data you can see the data. You can track it with our statistic, and it also really intuitive. Even your grandma can use it really fastly. Okay, so here we were doing some trying. Sorry, I will put again the video. Okay, so this was representing the different stuff of our project, and here you have the website. If you see, you can see that it's really easy to use, and everyone can use it. And this was a test. We were checking the time. We were checking the light. When you are adding light, you can see that it's automatically going up in our website. So this project it's done by a good team, my team from EIS and Recon, and we were separated in three groups. We had sensor team that worked with the sensors, and they were trying to catch the information, the light information, humidity, etc., to send it to the server that is treated by the backend. I was working on the backend. We use an MQTT server that helped us to have the information and send it to the front end. That made a really good work with the project. Our website is so beautiful, and I'm proud of them. And actually, we have the hardware team that make all the house and features. So actually, I wanted to tell you that our project is not a simple project. Like smart building is not a simple project. It's a vision that can help us, each one of us, from, I don't know, Gran Canaria hotels or school, I don't know, how can I say it? Or school rooms to analyze like the energy that you use. And we wanted to show people that energy stat is not that complicated, and it should matter to us to save our planet. This Makeathon was really good, and we had a really good moment too. In fact, and it wasn't just about coding, it was about knowing that innovation, it's about teamwork, about people, and knowing that the dream that you had actually can be the future solution of the world. Thank you very much.
Thank you very much. No, it's okay. Good job. Thank you, guys. All right. All right. Thank you so much. Up next, we have the gold sponsors challenges coming up. So up next on stage is the blue bucket from the Vishai team.
Can you make sure that the video is on mute?
It's on mute?
Can you make sure that it is on mute?
It is muted or not?
We need it mute.
Okay.
Yes.
All right, hello everyone and welcome to our presentation. So we are Team Blue Bucket. So our project was to build a so-called bucket which could monitor water quality, so hence the blue part. So the motivation behind our project was that global water quality is decreasing, and we wanted to create a really easy to use all-in-one device that you can use to measure if your local, I don't know, lake or river or ocean is safe to swim in, or to water your plants with, or to fish maybe. And when you have then collected this data, we want you to be able to send it to a server and kind of establish like a global community of everyone measuring their water quality so everyone can access it. To tackle this project, of course, we first had to decide on the sensors we were going to use. So we chose pH, conductivity, or P, temperature and dissolved oxygen. And to fit all of those sensors inside of like a bucket, to make it watertight, we 3D designed this bucket on the very first day. On the second day, we went on printing it. We also added a display so you can see your data right away. You don't have to wait for it to be sent to the server. We also did most of the embedded programming on the first day, and we also established like the most important electrical connections, so we could already do the very first test. So right here we are testing, it's just a bunch of cables at this point, but luckily everything was working and we got our very first data right here. So you can see this is like a few plots over time, just a few minutes from the fountain outside. Then on the third day we set up the whole backend, so the server, the database, and we're also using Grafana right here to visualize several plots or graphs of our data. And of course, we finalized all other open ends. So, 3D printing, waterproofing, everything, code issues, to finally have our finished prototype, which Jeff is also holding right there. And the next slide will be a video demonstrating the whole thing in action. And Jeff will walk you through it.
Then, as you can see, is as easy as you can just take the device, you submerge it into the water. It could be either a river or an ocean, wherever you want to measure the quality of the water. So you put it on, and it's going to upload all the data to a server, and then you will have it plot. But in case that you don't have connection to the internet, you can also see on site the data on the display. And here you can see a map of everything. Because, I mean, it's not only about taking the data and just uploading it. The idea is to have all the data public so everyone can see it. And even if you don't have the blue bucket yourself, you can still check the data before going to swim or fish. And of course, you can have all the data timestamped from every place. And this is our team. I would say this is very multi and interdisciplinary team. We are from 3 different continents, and we have, two special mentions to Professor Neve and Professor Ingabuta, who were our coaches, especially helping us in the analysis of the sensors, as well as for Ahmed and Emir here, who helped us really a lot and supported us in the connection with the servers and the calibration with the sensors. That was really, really time-consuming. And yeah, thanks a lot.
Thank you so much. Thank you. Oh, you got a lot of fans there. All right, up next on stage, the team NXT Innovation Optima Challenge. Wie viele mit? How many mics? One. Geht ruhig in die Mitte und vor. Die Bühne ist groß.
Okay, I'm just starting. So, hi guys, we are Next Innovation. We're students from Reutlingen University as well as Aalen University, and we collaborated with the company Optima on this project. Shout out to them. So, just like every company, there can be problems when you produce. For example, faulty packages. This was exactly what our problem was. Our industry challenge was to find a mechanism to eject these faulty packages and to sort them out during the process without interrupting our product flow. So, our vision was to have 100% good parts, 0 dependencies on cycle time, product size, or product variety, to be able to have 100% economic efficiency and correct sorting in the end for our company. Yeah. So, how did we do that? Because you can have many different mechanisms, we started with our TRIZ methodology. We tried to find different approaches how we could solve this problem. We could tell you all of the different discussions that we had, but to make it short, we came up with a small solution, which is simple, effective, and yeah, just scalable for our company, but as well as different companies that might use something like that. So, our project team was divided into 3 main parts. We had sensors, the ejection function, and the conveyor belt. The sensors made it possible for our sensors to, for infrared sensors, to detect false packaging and also trigger our mechanism in the end. Then we had the ejection function. Like I just said, we had different possibilities that we came up with. Our solution in the end was a smart flap that kind of sorts all the false packaging out from our conveyor belt, which I'm coming to next, because we also have a conveyor belt, because we want to show you guys how this thing works. We need to be able to transport our products. That's why we also built a conveyor belt that we will show you in the next slides. And of course, we also had supervision from our professors, but obviously, of course, from our company, Optima. So again, shout out to them, and thank you for your help and guiding us through this process. Coming to our prototype, you can now see our conveyor belt, which transports our packages, in this case, hygiene products, from one end to the other. And our flap, you can see the end product on the, for your right side. And this flap kind of sorts out all the false packaging. And yeah, we had a lot of fun during this project. We had a lot of crafty engineering, programming, as well as hands-on prototyping, as you can see, and came up with this solution in a very short time. But we all learned a lot. And also thank you to ITQ and the Smart Green Island Makeathon. So yeah, I hope you enjoyed it as well as we did.
Thank you so much. Did you do the video at the end yourself? We did. Okay, Fidel, get their numbers. All right. Up next on stage, we have the Lawrence team, Angieta. Welcome on stage. You need to,
Thank you very much. Okay. Okay, all right. Thank you very much. And my name is Shao, and we are representing our team, Angieta. And our challenge was about the water flow meter. And why we are doing this in almost every building, residential and industry and hotel, there is a lot of water being used every day. And what we want to do is we want to monitor the water flow, water usage in the real time, and beside of the regular water usage, like in the kitchen, in the pool, in the bathroom, there are problems that can occur. Problems like if someone forgets turning off the water faucet, or if a water pipe bursts, and in that case, a lot of water will be lost and wasted, and that is also causing a lot of damage. And we want to detect those kind of problems. And how to do that? We came up with ideas that we will integrate the smart water flow meter and connect it to our Arduino so we can measure the water flow in real time. And when there's some unusual water usage detected, then we can send out alert message. And for this purpose, we have, as you can see, we have connected the water meter to our Arduino. The sensor data is sent to the computer directly, and also on the computer, the data is being analyzed. So here we didn't collect real data, but we have made up data of normal household water usage, where in those two cases, with a small water leakage across a really long time, and also a big spike in water usage that can be understood as water pipe burst. And in that case, a small an alert message will be sent directly to your phone, so you can so you know what happened in your your household. And we had today another idea. This idea is to implement another sensor to the same system. This sensor can be, for example, an optical sensor to monitor the water quality. With that, we can actually, there's a paper writing about this low-cost autonomous optical sensor. And in their study, they already showed that the sensor can detect changes in opacity and color change in the water that can be traced back to potential pollution events. And yes, the sensor is used in the same real-time sensor, real-time monitoring system. And yeah. So that's all for us. Thank you very much for your attention.
Thank you, Josh. Thank you very much. All right. Before we continue with the next team, who this morning at 9:35, some people announced the Pilates session. Who joined the Pilates session this morning? Okay, that's 5 people. And who did not join the Pilates session this morning? Okay, you are lucky. We have one more chance to do Pilates today, so let's all stand up and have the Pilates guys come on stage. Everyone get up. Okay. I got a small briefing, so I hope I'm doing this correct. And maybe you don't look at me, but you look at the ones next to me. Where are those? Okay, they're coming. So they know how to do it, and I try my best. And let's do it. Okay, so first we're going to start with going a bit of this. Okay, what are the legs doing? All right. Okay, now let's take your right arm up and bend over even more. When it hurts, go further. All right. Okay, and the other side. We should have done this while watching the video from Bogota. Okay, and one more time. All right. And the other way around. Okay. Okay, let's go like this again. Okay, now let's see how far we can go down. Okay. Okay, if it hurts, go further. Okay. All right, then back up. And now we're gonna do, like the Spanish know better, we're gonna do some hips, okay? All right. Okay, and now the other way around. Okay. And now for the end, let's do one jump as high as you can on the count of 3. 1, 2, 3. Nice. So thank you for your participation. I hope no one got hurt. Great. So, up next on stage, we have the Visual CE team.
Yeah, hello everybody. We, the team Visual CE, are a team of mixed students from Germany, from the University of Allen and the University of Munich, and we collaborated with the company Lawrence on our project. We developed a circular economy demonstrator. Lawrence is a pioneer in circularity, as they already managed to reuse 80% of their components and therefore have savings in energy usage, in material usage, and therefore savings in costs and CO2 emissions. Maybe you already have heard these facts, but on a company level, the question has to be asked: how is a circular economy? How can a circular economy actually be achieved? So we set ourselves the goal to demonstrate circular economy and came up with a concept for a table demonstrator where we show all the entities and necessary connections for making circular economy work, and connected it to a dashboard where the values for energy usage, for costs, and also the CO2 emissions are being shown based on the settings you choose on the demonstrator. So, and the last step is that we build up the demonstrator, and I will show you now all the steps in the demonstrator. So at first, the water meters from Lawrence are being delivered to the quality management facility of Lawrence. And there they are being disassembled in their components and assessed if they can be reused. Furthermore, of course, if a component can be reused or not is based on the lifetime of a component. And you can choose for each component what the product lifetime is. And on the right side, you can see the change in the dashboard and the savings. In the next step, if the components can't be reused, they are being recycled. And so recycled materials can be used to create new components. You can also set recyclability rates there. And on the right side on the dashboard, you see again the benefits of it. In the factory of Lawrence, then the single components are being reassembled for a component. And of course, if there are not enough reusable components, you need to order new ones. Therefore, you press a button and new components come from the conveyor belt. And then at the end, the assembled water meter goes back to the households. Of course, you also save costs and CO2 and reduce CO2 emissions if you use renewable energies. So the renewable energies from solar and wind go to the factories, plants from Lawrence in the end. So with our demonstrator, we hope we can show that circular economy is possible and also profitable. And yeah, thank you for your attention. Thank you to Lawrence for all the data. And thank you guys from ITQ. We had a great time.
Thank you. Thank you so much. All right, up next is the team from the Myler challenge. Give them a big applause.
Hello guys, my name is Matt and I'm going to present you the Makeathon 2025 Hooklift Challenge by Myla Kipper, supported by MVTec. We had a goal to use this truck to detect the container, position it correctly, hook up the container and drive off safely. For that we assembled a nice team of a lot of people from FH Technikum Wien, Fachhochschule Dortmund, Hochschule Arnhem, Universidad de la Laguna and the BBS Jever. Afterwards we split up directly again into two teams. One team for the truck to figure out the movements of the hydraulics and the truck itself, then to let it go and drive and pick up the container. Next up we had the vision team. They had the task to figure out how to use the cameras, first of all by taking a selfie. Then they created a 3D model of the container to do pattern matching and point cloud actuation, as you can see on the last slide. And in the end, we integrated both systems into a demonstration that we have here in a short cinematic. So, this is the moment where I want to thank every sponsor, the ITQ guys, but most importantly, Myla Kipper. Thank you.
Thank you so much. Up next on stage, we come to the challenge of the Kronos guys. Let's welcome them on stage.
Hi and welcome to the final pitch of our Banana Cup Challenge. Crohn's and MathWorks were so nice to sponsor us for this. Can I just do it myself? I'll try this. For our challenge, we wanted to make a banana cup. So a cup made of banana fibers to make it more sustainable to use one-usable cups. For this, we determined that we should split our group into 3 teams: Team Robot, Team Automate, and Team Cup. And we also had the help of our team member of the week, our Igus robot, the Igus robot, Roberta. Thank you very much to Igus. Now, of course, the first step is finding out how the process is supposed to work. What steps do we take? And for this, on the first day, Team Cup determined 5 steps. First of all, we, of course, need to get our fiber-water mixture, which is called pulp. So we put some fiber into water and then mix it up to get this pulp. Afterwards, we mold it into our first mold. So we suck it in with a vacuum, and then we have the fiber in the rough shape of a cup. Then this is placed on our other mold, there the vacuum is switched to the other mold, so the cup is sucked onto it, and then we continue with another pressing and drying to get the shape nice and smooth. Then we of course want to make sure that it's watertight, so we coat it with a mix of wax and oil. And lastly, of course, you're able to go and have a drink of it.
Okay, all of that is unfortunately not really automated at the moment. So the task that we, Team Robot, had was to automate it. As you can see right now, the first step was to basically put the mold into the bucket with the fiber and suck it into the mold and drive back up again. Yeah, basically we used an Igus robot, but other than different groups, we didn't use the Igus program. We instead used MATLAB. And yeah, I thought the same thing. Why? Basically, it has nothing to do with them like being our sponsor and paying for half the stuff and bringing their specialized software tools and stuff like that. No. The reason is state diagrams. Yeah, because we can control our robot with a nice little tool, and we can basically teach our positions in a state diagram. And then if we zoom out, we can basically just have a nice overview over the different states that we have, which tell us exactly what the robot is doing. For example, approaching a position, driving down to his position, driving up again. And that way, we can pretty easily see what the robot is currently doing, what it's going to do next. And even if you have never written a robot program before, if you don't know what if conditions are, if you don't have any idea of while loops, you can still understand how this flowchart is working. And that's pretty nice because we just got a flowchart from our cup team which says which step we had to do, and then we could basically translate it into these state diagrams. Yeah. That is pretty nice. In the end, everything worked. And so yeah, I will give it to the next person. And that's the next.
Right, so now that you've seen the robot dip the mold into the mixture and suck in our first pulp, we go over and move with the robot, the mold, onto the other mold. So we're able to press the cup shape onto here and dry it. For this, Team Cup had, of course, the issue of how long do we need to suck in the pulp to get a functioning cup. How long do we need to dry it so it doesn't become soggy and not watertight? And also, what is the optimal distance of the heat guns so we don't burn it or don't have the optimal state of dryness on the cup in the end. Also, of course, as mentioned, we have the system of the vacuum for which we did the assembly of the tubing. So the valves can be automated by the automation team.
Hello, I'm Thomas from the automation team. Our job in this project was to integrate both the cup and the robot teams using microcontrollers and all the electronics. So what we had to do was control all of the valves, all the heat guns, to make sure they're all on when they need to be respectively. We also were controlling the stepper motors and the servos in order to initiate the waxing and to make sure the wax doesn't dry as we're waiting for the robot to move across. We programmed the Arduino using the Arduino IDE, not MATLAB. Next. There you go. Now you can see the waxing in progress as the servo spins to make sure the cup is properly coated, and then we can move away from it when it's done. So here's it in the full.
Yeah, basically we see again the robot took all of the fiber, then it presses down again. Now it will move up in a few seconds, and then it will move down again to press it again. While all of that's happening, the valves are also changing, so the robot stops sucking the cup up, but instead pushes it out, and the pressing form basically sucks on the cup so that it stays there. Now it's getting heated, and after the heating process, the robot basically picks it up again, and then goes to the waxing station. Now it's getting, yeah. Okay, that looks nice. And now we basically have the perfect cup. And yeah, you can actually drink out of it. And we did so with nice banana rum, and cheers. Yeah.
Thank you, everyone, and thank you, ITQ, for the nice event.
Thank you so much.
Yeah, I just wanted to, I forgot one slide. Is there some banana shots left?
Okay, I'll see you there, hopefully. Okay, well, first of all, thank you all so much. This was some great presentations. I think you can be real proud of yourselves. So once more, let's give each other a big hand. So we are now finished with the presentations. We have a few more things coming up, and Anis has a special surprise for you. He and the media team worked hard to show you something. Anis.
Don't have to speak. Yeah, wow, okay, perfect. Thank you, Jonas. Thank you to all, you all. It was really an amazing event, and I just brought for you a little surprise, as Jonas mentioned to you. But first of all, I would like to ask, how was it? Yes. Excellent, excellent. So exactly this kind of emotion and feelings, we prepared something similar like this. Just show up. Okay, it's just a part, but if it's not function, it's okay. It's okay, it's okay. But a big applause. Yeah. That was not obviously, but it's okay because this surprise will just follow you to WhatsApp and MetaMost. After our just closing event, I will send you the link, so enjoy it there. But before to that, a big applause to my colleagues and to our dream team of our agency, Fidel, Jakob and Stefan. Big applause. Thank you. Thank you very much. The last thing which I really appreciate is two little things. The first thing is I hope you got all our picture links of each day, so please share them, use them, feel free, and if you need more content or material, just write us an email or contact us. And the second point is I was sending to you today a feedback formula. Please fill in and give us your feedback. That is very important to improve each other or us, and yeah, to know what's to do next for the next Makeathon 2026. Thank you very much from my side, and see you.
All right. Well, speak. Oh, okay. You need a mic? Yes. You too?
Is it working? Yes. So hello everyone. We just need, are going to take a few minutes, your attention, and yeah, sorry for that. So we are Moritz and Jan, and we are from the UAS in Aden, and we think that, that we speak in the name of everyone if we say that we are very grateful for this unique opportunity to be here in the Makeathon of Las Palmas in Gran Canaria. Which is why we want to thank Dr. Stetter, the whole team, the ITQ team, and all the sponsors and their teams who and their teams who made this possible for us and helped solving our problems during the last few days. It was truly a great time, and I think it's applause worthy. So our professors prepared a little gift, and we want to hand it out to Jonas and Lukas, if he's here.
Let's have the rest of the team
Lars,
coming up, the whole ITQ
Lars.
team. All of the ITQ team.
Let's come on stage.
We had a lot of people helping you in the kitchen, in the background with the material. Really proud of them.
So now it's a big time. We've got a 3D printed riddle, and we try to give it as a small gift to you as an, we can do now a little bit of riddle solving here on stage. Lars and Jonas, if you'd like to come here, we do a little bit of live...
live what? No,
riddling. I don't know what's the correct term. But it's so you have to solve the words what are written there. You have to look to the exactly. Yeah, you figure it out. I don't tell too much. Then it's a little bit senseless.
I see an A, but turn it around, please.
No, it's fixed there in the position I'm standing.
Okay, there is an M. There's two O's there. There is a Makeathon if I read from this direction. And
yeah, that's right. And now it's your turn, Lars.
What happens if you look from here?
It's a little bit difficult. I need, first of all, a little bit of time to figure it out either. But
Dr. Stetter, ITQ.
Yeah, you're right, correct. Now I'd like to hand it over to you. So, thanks for your attention. That's our small gift for the whole team. And we've really enjoyed it, and that was our part. See you later when we disassemble our models. That's a little bit sad, but then we grab some beer. See you later. Bye.
Thank you so much. Thank you, that's so nice of you. And once more, thank you to all of the team. You did an awesome job this year, pushing on every end. So thank you so much, all of you.
Well, Jonas and the rest of the team, well, this is always a very sad moment for me to see how many people are involved and how much it costs. Well, actually give them a big hand, because they are really working hard. it's always me with the silly ideas, and then they have to suffer. Huh? Well, but it's really great, and yeah, I'm really grateful, and I think this is a super event. And now, well, to fill up the stage a little bit more, I would be pleased that the Platinum sponsors join us. Come a little bit on this line to. Well, I think we had yesterday a nice event at my home, and well, I gave some guys and girls from this group the opportunity to speak to all the others, yeah? And they were really keen on to do it today in front of you. Well, who's first? Patrick.
Hello. So at the end, what to say, Rainer? Of course, it's always a pleasure to be here. It's an amazing event. Of course, it makes a lot of fun to work with you guys. That's quite cool. I said it before. I'm really proud of the team of Moore, but of course of all of you, what you did, what you reached over the last 3 days, and of course a really big thank you to all of you that you organize it, that you make it possible to do something like this. And it's really cool, and I hope we will meet next year again.
Well, about this we have to talk. Well, it's now your choice to whom you want to hand over to MVTec. There are 3 persons. Choose one.
Hello. Philip didn't want to, so I did it. So I also want to say thank you. We all 3 were the first time here from MVTec. We had a really great time. We had really cool teams that were very motivated and self-organized, did very cool presentations. And I hope it wasn't the last time that we joined Makeathon. Like
I will talk with your boss. Yeah,
yes, but also for the 3 of us, just not for our company, but also we 3. We hope we're going to come back again.
Yeah.
And yeah, I hope we all have a nice closing event now.
Thank you.
I'm going to hand over to Igus.
Now your choice.
Yeah, I think we can only say the same. Thank you very much that we can be here, that you offering this nice event that brings us all together. You did very great, all of you. We learned nice people in our group, also you. So big shout out and thank you.
Thank you so much. Well, give the Platin sponsor a special applause. Big hand. Well, we were talking about, do you want to do it again? Well, actually, we started already to plan it for next year, yeah, because after the Makeathon is before the Makeathon, yeah? And therefore, well, one question: if you see these people, how many people you see from the sponsors, and compare it with the team behind them? This is a major problem. Yeah? I'm really grateful that we found these sponsors as well, the other sponsors. Give them, the others as well, a big hand. But we really, as ITQ, have a big problem, yeah? Because this costs a ton of money. Yeah? Such an event costs $500,000, yeah? To bring all these people and the preparation. This is not only this week. We're working already then for half a year, 3/4 of a year. Yeah? And therefore we discussed already today with a lot of professors what we can do for the next time. And as well, I would ask you all, please go home and talk with minimum 3 people and make marketing for us. Yeah? because actually I talked with a nice lady from Industry 4.0 Aliens. I could fill this room with young talents without any problem. Because we have meanwhile in the last 10 years so many connections and so many friends there. And we this time we had 70 university and schools. I could put there 100. No, without any problem. And if I go home to Germany, everybody says, we don't have Fachkräfte, we don't have innovation and so on. Well, and I say, okay, here we have a great opportunity to learn, to get in touch with each other. But then mostly I have to do with old men like me. And they have no fantasy, and they can't believe that you come here for several days and working hard. This is totally out of their scope, totally out of their imagination, that young people, this crazy generation Z, is willing to work hard. And therefore it would be really a pleasure for me that you, all of you, talk with the people which you know and to make marketing, because we want to do it again next year. And we can make it even bigger, and we have as well, hopefully some of you saw that we start with education programs with starting at that size. This is the future for you. You are much younger than me. That's your future, not my future. And therefore I would really appreciate that all of you help me. And in the starting years, I gave everybody the work package, talk with minimum 3 people, and convince them that it's great. And and thank you. My wife is always a little bit, she wants to hurry up. She's always a little bit nervous. Well, but afterwards she tells me, we have to look after the money. Well, and by the way, come, you want to speak as well. She loves to speak the English, especially in front of big groups. Well, now, to sum up, and I want to finish, we want to do this event next year again. We will have probably the problem that this site won't exist anymore because they want to make it nicer and bigger. And therefore we have to transfer it, the whole event, to another place, which is much nicer, but the double of the costs. And therefore we have next year for sure even a bigger problem to finance it. And therefore please help me that I can help you. Well, and then we have, you saw as well this Curaçao thing. This is quite crazy because people ask me to help them to make their island blue or green. And this is really cool. Some years ago, people, when I told them we want to make this island green and sustainable, everybody thought, But now we have another example, and now I can play, well, there's one island, there's another island, and therefore this is a big, nice situation. Okay, then I think I hand over to Jonas, and thank you so much.
Thank you so much, Rainer, and also thank you so much for putting so much work and energy and enthusiasm into this event, into making this happen, and really pushing hard to make this happen, even if the circumstances are hard. So thank you so much, Rainer.
Thank you. Well, and today we have beer, and this is the last day you can drink all the beer.
Okay, speaking of the rest of the evening, first of all, I will send all the ITQ team back to whatever you were doing. Thank you so much. And also the sponsors are now free to go. So now back to work. I'm going to be telling you a bit about what's going on for the rest of the day. So there's Carnival in Las Palmas. Some of you might have noticed some hints. So we will do a mixture between Carnival warm-up and clean-up. So maybe let's first focus on the cleanup and then focus on the Carnival preparation, because otherwise the cleanup is a mess. So first, regarding the prototypes, please disassemble them and bring them back to our material booth or to the Passau guys, to the workshop. If you want to continue working on your prototype, talk to us at the material booth and we will discuss if you can carry some things with you. Yeah, this is about the prototypes. Please bring all the tools back. It would be nice if we have them all in order for next year. And just ask the people in yellow if you can help carry something, if you can help, I don't know, help something. That would be really nice. So we are done really quick. And then we have, some of you might have met Jesus, the guy with the hat at the bar yesterday. So he can't wait to party tonight with you. So the idea is that we now do maybe an hour of hard cleaning, and then we do an hour of hard preparing, and and then we all take the bus to Santa Catalina. I will share the maps location with you on the WhatsApp group. So hopefully we will see all green and yellow shirts on the Carnival there.
Well, this is actually what I wanted to say. It's Carnival, yeah? And we have really nice T-shirts, yeah? hard to miss, yeah? And therefore I would appreciate that you keep your T-shirts on. Yeah? The people are asking you why look you so silly, yeah? And then you can talk with them. Yeah? And as well, we have already, thanks to Naira, a big hand to Naira. No. Well, that you talk with locals and as well international guests here, what we are doing here to spread out the word.
All right. So I hope I didn't forget anything. We have, yeah. Please help us. Please have fun tonight. And there is some food and some drinks prepared, so that's why they were working so hard for the last hour. See you next time. Thank you.